My dear students and parents, in this video we are going to derive the formula to the drift velocity in the chapter current electricity in the subject physics to the plus 2 Cbse and IIT students. By God's grace, my educational videos are available in YouTube to 10th Cbse, plus 1 Cbse, plus 2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. We know that the formula for the velocity is acceleration into time. That is velocity v equal to acceleration small a into time t, v equal to at. We also know that the formula for the velocity equal to distance by time, but here we are not selecting that formula, that is velocity equal to distance by time. The reason is, when the electrons are flowing in a conductor, they collide with the other electrons, positive ions, heavy fixed ions. After collision, they emerge with the same speed, but the direction is random. Since the direction of the electrons is random, the average velocity of the electrons is 0. So how can we get the average velocity, that is drift velocity of the electrons? When we apply the electric field, now the electrons are accelerated, that is the electrons are drifted in a particular direction. So we will get the average velocity of the electrons at present. Since the electrons are accelerated, applying the electric field, we are taking the formula containing acceleration. Then here the time is denoted by not t but tau. Tau means average relaxation time of the electrons. When the electrons are colliding, the collisions between the electrons does not occur at a regular time. The collisions also occur in random times. After the collision of electrons, the direction of the electrons is random. Here the collision between the electrons is also random. It does not occur at regular intervals. So that let us denote this time, that is the relaxation time, as tau. So that we are taking as the time as tau. So the formula for the drift velocity now becomes as drift velocity Vd equal to acceleration small a into average relaxation time tau, Vd equal to a into tau. Then we are going to write the acceleration relating the force and mass, because we know that the formula for the force is mass into acceleration. From that formula we can get the formula for acceleration as force by mass. That is, we know that force equal to, that is capital F equal to mass small m into acceleration a, that is capital F equal to m into a. Therefore what is a? A equal to F by m. Now we are getting the expression for acceleration as capital F by m. If we substitute capital F by m in the place of acceleration in the equation, velocity, that is Vd equal to acceleration into tau, now the equation for drift velocity becomes as F by m into tau. So initially we are getting the equation for drift velocity as acceleration into tau. Now we are substituting F by m, that is capital F by m, in the place of A. Now we are going to substitute capital E into small e in the place of force, because here the force is the electric force, that is the total electric force. We are going to write this total electric force capital F as capital E into small e. What is capital E? We know that capital E is the electric field. What is electric field? Electric field is nothing but the force experienced by a unit positive charge. Here the force is not experienced by a unit positive charge, but the force is experienced by a charge of an electron, so that we are multiplying the electric field with charge of an electron small e. So we are getting F equal to capital E into small e. After getting the expression capital F equal to capital E small e, we are going to substitute this capital E into small e in the place of capital F in the equation Vd equal to F by m into tau. If we substitute, we will get the equation as drift velocity equal to capital E small e by m into tau. This is the equation for drift velocity relating capital E and tau. What is small e? E is the charge of an electron. What is the charge of an electron? The value of charge of an electron is 1.602 into 10 to the power of minus 19 coulomb. What is small m? Small m is the mass of an electron. What is the value of mass of an electron? The value of mass of an electron is 9.11 into 10 to the power of minus 31 kilogram. So small e, that is charge of an electron, small m, that is mass of an electron, are constant. Hence, if we know the value of electric field and average relaxation time, we can find the drift velocity. There is also another formula for the drift velocity, that is drift velocity Vd equal to I by NAE. Here I is the current, N is the number of electrons per unit volume, capital A is the cross-sectional area of the conductor taken, the E is the charge of an electron. So in the sum, if they are giving the value of current and cross-sectional area of the conductor and also the number of electrons per unit volume, we can select the formula for drift velocity, that is Vd equal to I by NAE. The another formula for drift velocity relating current, number of electrons per unit volume, area, charge of an electron, that is Vd equal to I by NAE. You can see the derivation of that formula in a separate video. In this equation, drift velocity equal to capital E small e by m tau. This E tau by m is the mobility. What is mobility? Mobility is also drift velocity. So what is the difference between mobility and the drift velocity? Mobility is the drift velocity when one unit electric field is applied. Therefore, the difference between mobility and the drift velocity is, in the case of drift velocity, more than one unit electric field will be applied. Both are drift velocity. So if we divide the drift velocity Vd by capital E, that is electric field, we will get the drift velocity per unit electric field, that is small e tau by m. This formula is arrived from this formula. Therefore, the formula for mobility Vd by E equal to E into tau by m. My dear students, if this video is really beneficial to you, you can share this video with your friends, relatives and classmates. You can also subscribe my channel. If you want to know all knowledge in this chapter, I appeal to you to see all my videos.